you are here with us tonight. Do you hear me well?
Maybe there's some delay.
Okay. Okay, now we are live. Hello, everyone. I'm happy to see you are here with us tonight. Do you hear me well? No, I don't think they're...
Maybe not yet.
Okay. What about the rest? Do you know how to use the platform? On the right side, you can write anything. Okay. I'm happy to see there are people here with us tonight. My name is Ivaylo Donchev, and I'm part of Hack Bulgaria and one of the organizers of Django meetup in Bulgaria. Tonight we organized Django meetup for second time online, and Ivaylo Donchev is with us. He's a software developer. Hello, Ivo. He's software developer at HackSoft, and tonight's talk is going to be about rules of thumb for queries optimization. So I just wish you good luck, and later we will continue with questions and answers.
Thank you. I'm going to share my screen, and let me share my entire screen. Okay, can you see my screen?
Yes, I see.
Great.
What about the rest?
Sorry?
What about the rest? If everybody are seeing it?
Yeah, I can stop the camera if it's going to break. I think. Okay. Do you see my screen?
Yes.
Great. So, okay, we're going to talk about rules of thumb for query optimization. But first, a few words about me. My name is Ivo. I'm 24. I'm part from HackSoft. I'm working with Django for 4 or 5 years. We're basically using Django in most of our projects, and we're using Django with DRM. I mean, DRM is almost irreplaceable part of Django. And I really love playing with it. I really love reading the implementation because it is kind of long-term investigation to learn about it, because Django will use DRM till it uses any relational database. And I prepared some tips for how we usually deal with queries with heavy views and APIs, how we usually optimize heavy data fetching from database. And all we will need are these 3 tools. So all the examples use the Django REST framework because it's the most popular API framework for Django, and it provides really nice interface for previewing the HTTP responses in the browser. And we'll see the rest for after that. Okay, this picture shows the basic MVC architecture for every web application. And what's usually happening is that the user opens the browser. The browser, or the front end, the left part, is sending an HTTP request to Django, which is the controller. And Django is sending one or more SQL queries to a database to fetch some data, and it's returning some response. And this is basically the the pattern that all list or detail APIs use. But just a thought, the main job of the list and detail APIs is just to forward data from the database to the front end with as minimum job from the application as possible. What that means is that the database is good at collecting data, good at storing data, it's good at making data calculations. The Django and the Python are good at providing business logic. They are good at just forwarding the data from the database to the front end. So here's an example of a simple Django REST framework API. What we have here is a class simple API view, which has a get method, handles the get request, and a REST framework serializer, which basically serialize some Django RM model instance. And if we open this API in the browser, we won't see the raw HTTP response. We'll see this kind of beautiful page which shows the HTTP response rendered object by object. And I'm going to show a demo in the code. It's half a presentation, half a demo. So if you see my right part on the screen, that's the second tool. That's the first tool, the Django Debug Toolbar. Django Debug Toolbar is a third-party application for Django that puts a middleware in every request and tracks every single SQL query made to the database. So I prepared some demo project, which I'm going to run now. Run server. Demo. Okay, I hope you see my screen clearly. This is showing the HTTP response, and the right part has a SQL section in the Django debug toolbar. If I click on it, it says you have made one query, which is a select query, and it says the exact stack trace where this query is being sent. So that's how all the examples in the presentation will look like. It's just an API and a browser page where we can see the result. So here's a thought on the common problems that we face with the fetch APIs. By fetch APIs, I mean list or detail APIs. Most of the times, the APIs are slow because we are making too much SQL queries to a database. And we are making too much SQL queries because we haven't used our SQL joins wisely, or we are making some calculation in the Django code, or the other problem is that some of the queries is slow. And this is a really common corner case with the Django RM to make a redundant SQL logic hidden in the query. And sometimes we just need to tweak our queries to optimize our queries on SQL level. And here's our first use case. It's the most common use case that we hit when using the ORM. It's the n+1 select queries problem. So we have two models, full and bar. Bar has a foreign key to full, so one full has multiple bars. And we have two for loops. The first loop is iterating over all the bars and access all the full names. What this code will make, it will make one query for all the bars and then it will make one query per object for all the bars to fetch the full relation. And the other case is the opposite. We iterate over all the full objects, and then we iterate over all the bar objects and get something. And this is why it's the AND object plus one for all the objects from the query set. And Django provides a really intuitive interface to solve this. And it's the select related and prefetch related functions. What they do is that they handle the joins. If we were dealing with raw SQL, we would select all the bars and we would join the bars table to the full table and have all this data automatically in one query. The other way to achieve this is to select related. The opposite one is the prefetch related. If you have a model which someone else has a relation to, you want to join the other table and have all the objects with one query. And we have a simple API. Let me open the code. We have a simple API that fetched all the article objects. Article is some model in the database. All the article objects gets the first 200 and pass it through the article serializer, where one of the properties, the author name, is accessing one of the relations, the author. So if we see the models, the article has a foreign key to the author. So when we open the API, we'll see one query for the articles and 20 queries, one for each article to fetch all the authors. It's taking some time to load. Yep. So if you want to solve this, we just need to put the select related. And if we just make one query, which query will contains the inner join between both of the tables. So here's the first rule of thumb, the first keystone. If you have relations, the select related and prefetch related methods are the way to deal with them. But here we have two more models, invoice and invoice item, where the invoice item has a relation to the invoice. So one invoice has multiple invoice items, and one invoice item has its price calculated as the quantity multiplied by the unit price multiplied by the tax, because we always have some tax. And the invoice total amount, total price, is just a sum of all the invoice item prices. So we have another API. We have API where we want to show all the invoices, and for each invoice, show all the price. I have prefetch related the items, so this will make one query. I'll just open the example in the browser. Still loading. Okay, this will take some time. We have prefetch related all the items for each invoice, and what the serializer will do is that it will iterate over each invoice and calculate the total price, which is a sum of all items price, which price is a result of this equation. And here we have, maybe the example is not, okay, I've removed the prefetch related items. This should make just one query. Okay, the API took 2.5 seconds just to calculate all the prices here. If I remove the total price from the serializer, it makes a huge difference because we skip all the calculations made by the Python code, which is basically so. And the API will return the result refresh. It's most of the data that's slow. Fetch 800 invoices. And this is not a good way to calculate something like the total price. We have simple math calculation that we made the Django to calculate for each invoice. But as we said, the main goal for each list or detail API is just to fetch some data from the database and forward it to the front end. The good way to do this, if we were dealing with raw SQL, we would just make SQL annotation, which will just calculate on a SQL level, on a database level, all these prices, then group by all the prices for each item, and add it to each invoice. So if you want to do this in Django, we will do something like, I'm just going to open my shell. Shell plus. Okay, we have the invoice item model. The logic for calculating the price for the invoice item is quantity multiplied by unit price multiplied by tax. If I want to calculate this on a SQL level, I need to say invoice item objects dot annotate. Annotate means everything inside it, every keyword argument inside the annotate is SQL annotation appended in the select clause of the query. So I can say total price equals to expression wrapper, which means that I'm putting a SQL expression inside, where expression is f. F means get the object itself on a SQL level, the object itself a certain column. And the column here is the quantity multiplied by unit price multiplied by 1 plus tax. And the expression wrapper needs an additional keyword argument, which is an output field. Because we are making some database logic, but the Django doesn't know what the output of this logic is. So we need to say to the ORM, okay, this is some database calculation, and the output of this calculation needs to be put in such field. For example, here the output field should be model.decimal field. And if you run this, close all the brackets. One more bracket here. import models. So I can say any name what I want here in the annotate query. For example, underscore total. I'll just save all the items in some variable. And if I get the first item, I'll have this property attached here. And if I print the query, I'll see that my logic is put here in some cast expression, which will handle all of what the property does. And what I still need to do is to calculate all this, what I just did, and group by all the items per invoice and append the result to each invoice. So I'm going to write this in the demo project. Okay, I have the invoice. I have predefined the invoice query set, and I have defined a collect method. Collect is just a sample name for what we're going to do. It's some method that will handle all the annotations. At the moment, the collect is just equal to .o. So if I say invoice item .objects .collect is the same like this invoice .collect is the same like saying .o. So we need to get all the invoice items annotations and group them by invoice. So what I need to say is annotate the total price. I'll put an underscore before this not to conflict with the model field, model property. And it will be the result in the group by of all the invoice items. The way to do a group by with Django is making a subquery, which accepts a query set argument and output field argument. The output field argument is a decimal field again. The query set argument is invoice item objects filter. We need just the invoice items for this invoice. So the invoice of each invoice item is equal to outer ref. Outer ref means this query set executed in the context of the subquery of the group by. So we need to somehow access the outer query of the SQL of the whole query. And the way is outer ref. The outer ref accepts a string argument that points to a column of the invoice query in the example. And I need all the invoice items filtered by invoice, where the invoice is equal to the invoices ID column.
Just a second. People are just texting. Could you please zoom in? Can you please zoom in?
Yep.
Okay.
I can. Is it better now?
Let's wait for a few seconds.
I hope it's better.
I think so, yeah. Okay. Yeah.
Okay. So what we're doing is making an annotation to the invoice where we have some new property total price, which is equal to subquery of the whole query, where the subquery I'll just move this in some variable to make it more readable. items subquery, items subquery. Okay, and I need the items query set here, which is this part. Items query set. Okay. So we have all invoice items for this invoice. Then we need to somehow group them by the invoice itself. It's a little bit tricky to do that with URM. The way to do it is to say dot values list by the thing I want to group the item by, which is the invoice. Then I want to get just the annotation, again values list, the group by class. So what I'm doing is first filter all the invoice items for the given invoice. Then I'm saying group them by the invoice, and at the end give me some annotation for them. So I need to put the result expression here in the last values list. And the expression here is the expression I just made in the shell. It was the annotation for the total price. For the price property. So I'll just copy it from the shell. I'll just copy the whole thing here. Okay. This is the price annotation. I hope you can read this now. So I'll say annotate price equal to price annotation. This part is what we did in the shell before that. Then we want to say, give me the sum. Sum is embedded function in the ORM. It uses the SQL, the database sum function. And we need to say the name of the field here, price. Let me check if I have made a mistake somewhere. Subquery. And what it says, missing component. Okay. Okay, I'm going to run this in my shell again. Or starting the shell. Oh, invalid syntax. It's dot filter. I'm missing the backslash. And again, the output field missing conf. Okay. I'm going to run the shell tools because it automatically imports all the models and settings in the shell. Saves a lot of work. Invoice.objects.collect. The expression wrapper is not defined. Django DB models import expression wrapper. And again, if it's not defined, yes statement, we have some and outer ref from Django DB import models, some something else, subquery. Okay, it should be working now. Then tap. And we need to reload the shell every time to get the new change. Okay, we have now the annotation, and I'll just get the first invoice again. And how did I name it? The property is the total price. It's total price, which is 0 here, and if the subquery don't return anything, it just return none. I'll print all the query sets total prices. And they're either none or the result. And this is really, really faster than calculating it into a model property. And if I print the query here, it looks like that. It says select the annotation that we made, group by invoice ID, and all of this is put in the select class of the query. So yeah, here's the annotation from the example. I have put the annotation, and here the second rule of thumb is that use database annotations wherever you can, because it saves a lot of time of your Django application and really makes the API faster, because it makes the Django skip the work it's not supposed to do. And here is some quick list of the ORM select query lifecycle. We have 4 steps to execute a query. The first one is construct. It's basically appending all the filters, excludes, and everything to construct the SQL query. The second part is the compile. The ORM have a SQL compiler part, which translates the ORM structure from the structure that's made by the filter chains to the SQL dialect for the database management system you're using. For example, for Postgres. We don't have much control here. It's automatically done by the ORM, but we have full control for all of the other steps. The next step is execute the query. This is the moment when your code actually sends a SQL query to the database. And as it sends the query, it loads the result of this query into low-level Python structures, which are usually just a list of tuples in the format you are fetching data. And the last step is loading the database data into the actual ORM structures that we are using it. For example, the ORM object from .o. So what we just did with the first 2 rule of thumbs is just constructing the query. The annotate is part of this, the filter and exclude are part of this, and we are done with it. So let's see this code example. I hope you see it. We have some multiple random query set expressions, and looking at this, it's not quite obvious where exactly the code is making a query to a database. I mean, we see some query sets, but for example, the first one with the print, we're comparing 2 query sets that will actually make a select queries to a database. And what will they compare? The objects that will fetch or the query set object itself? And I don't know about you, but it takes me some time to get how it is actually working. So what URL does is when you create the query set and start appending filters to it, it makes a mathematical tree, which is the query set itself, and it has the query object attached to it. The query object is some Python class, and the query object has these queue objects attached to it. The queue objects are all the nodes in the where class of the query. And it's all put in an immutable mathematical tree. So every new filter chain is a whole new tree. And when you chain whatever filter you want to chain, it's a whole new query set. So you cannot compare to query set at all. And I'm now going to open the Django source, which I'm not sure how it will look on the stream. We have the query set class implementation in Django, which has this iter method. Iter method is the Python class method for showing that something is a generator. And what the query set iter method does is it called the fetch all, and fetch all is saying if I have the result cache is the objects fetched from the database. If I have the objects fetched from the database, just return them. If I haven't, it iterate over some iterable class of the query set, and then save it to the result cache and return it. And this is the tricky part. So what we see here is that the query set is actually a generator, and the select query is being made as soon as the iter method is called. And we can easily check that if we open the shell, and this is the third tool we're going to use. Django extensions add a new command to the main GPUI called shell plus. Shell plus provides a new argument called print SQL, which basically allows you to see the database queries at the moment you type the code. So if I say invoice.objects.o, I'll see the exact query I've made. And if I get all the invoices, here, I haven't made any query. If I call the first iter method, I'm just triggering the query. If I call it more times, I don't do anything because it's all saved in the result cache of the query set class. So when I'm trying to optimize any query, my rule of thumb here is that the query set is a generator, and the fact that this is a generator is used to trigger a query. At the moment you start iterating over the query set, it's making a query. And if we go back to the example here, the first line is comparing two query sets. No iter method is called, so there's no query here. The second one is casting both of the query set at least, which will trigger the iteration over all of it, and we'll make two queries. This one will save the query set to a variable, but it won't trigger anything. But the for loop below it will. The second for loop will not trigger a query because it's already saved in the result cache. And the last one will trigger because the query set is an immutable mathematical tree, and every method chain on it is a completely different object. And that's pretty useful when you try to debug why some piece of code is making 100 queries where it shouldn't. And we saw that the iter method is calling some iterable class to iterate from. And the iterable class defines the last part of the query lifecycle. It defines what ORM structure will be used for the database data. By default, it is the model instance. It's the instance of the class of the model. If we call values, we receive a dictionary. If we call values list, we receive a tuple. And Django 3.0, I think, added the name true, which is actually another structure, name tuple. And the reason I'm showing this is if we take a look at the iterable class, for example, the one used from .values, it's a pretty simple implementation. It's just a simple iterable with iter method that iterate over all the rows fetched from the database and put it into some dictionary. It's basically 2 lines of implementation. The values list does the same thing, but it returns a list of tuples. The logic here is more complex because it's deciding whether it should be a name tuple or something. And the model iterable, the one that we use for .o, is kind of more complex. It's really more complex than the other. That's why it's slow. So if you have some big table that we need all of it from, using .o is not a good idea at all. I'll just run another example. Hopefully it won't fail. Let me check. APIs. Yep. Okay, I'm just making one query here, and my APIs loads for a second and a half. And the API, what it's doing is just iterating over some model, or the objects of some model, and doing some simple calculation. And if I just change this .o method to .values, which will return a list of dictionaries, which I have to handle here. The difference in the speed is it's loading twice faster than before. And it's making the exact same query, but it's keeping all of the logic hidden in the model iterable. All of this it's just being skipped. We're just receiving a list of dictionaries and do some calculations over them. So here, my rule of thumb is if we have heavier data, which means more fields per object or more objects, we just need a lighter data structure, which is either a tuple or a name tuple. And actually, for the list and detail APIs, I think the only use case that we would need an ORM object is that if we have some model property that we need to access, or we want to update or delete the object. So another use case is this function. What it's doing is that it's iterating over all of the objects provided, all the invoices, and it's attaching some property to the object itself. That's not a good pattern, but sometimes you need to do something like that. You need to get some data, not from the database, but from somewhere else, and just attach it to the object. But this has some disadvantages because at the moment you say invoices, which is a query set, dot all of the properties that you have attached disappear. And if you open the code again, here is the API that showed this example. We have all the invoices. We are calling the attach is expired dynamically, which is attaching everything. And if I open this API, it is here. But if I say invoices.all here, after I have attached the property, it will just say you don't have this property attached and it will raise an error. So this is kind of related to the previous use case because the iterable class is not part of the public ORM interface. I think it's not described in the documentation. It's not supposed to be overridden, but you have, if you override the iterable class, you have the freedom over the last step of the query lifecycle. You have the freedom to put the database data in any structure you want. And what you else have, you have the freedom to implement some method like map over your query set, which will be executed at the moment of loading the data into data structure. And this will be faster, and this will be executed at the last step, at the moment you fetched everything. And I've just implemented this in the demo project. I'll just open my models. So we have the invoice item, and the invoice item has a predefined query set. The predefined query set has just one method, which is called map. It behaves the exact same way as a normal map method. It accepts a function, which accepts an object and return an object. Just apply some function over all of the objects in the query set. So if I run this in the shell, I can say something like invoice item objects.map, where I put a lambda function. No, I'll just define the function. Attach property. And the function will just attach property ASD equal to 1. So I can say invoice item dot objects dot map attach property. Yep, typo. And I should return the object at the end. Return the object. Okay. So if I get all the items and I access this property, it will be there. If I say something like .map, I attach the property, then I say .all, which will return a completely different query set. The property will still be here, and will still be here because the logic hidden in the iterable class will always be executed in the last step, the step where you're just loading the data into the ORM structure. So whatever you change here, .filter, .everything, your property will be there. And it's not the best implementation, it's not the prettiest code, but it gives you the freedom to do whatever you want for the last step. So the rule of thumb here is if you need a custom iterable, just create one, no matter it's not part of the public interface. Okay, and here we have, let's say we have some really big table with many columns, and we want all of them into into our API. Every object is consuming some memory. It's not much, but it's consuming some. And if we have, for example, 100,000 of objects, it could just break the server. And the last example is doing this. We have some heavy model objects. Heavy model is some big class. It has like 40 fields here just to store some data. And we have 200,000 objects. So it's not a good idea to call .all here. The ORM has dot iterator method, which is used for this. Dot iterator method is, I'm going to open it. It's calling underscore iterator, which is just yielding from the iterable class. It's not casting to list anything, and it's not saving anything to the result cache. So it's not taking from your application memory. It's just yielding from it and yield to whoever is using it. And the last tip is that the extra query doesn't always mean a slow view. Sometimes you just need to make some 2 or 3 extra queries and construct everything in a Python level. But it's always depends on the use case. So you can check our Django style guide where most of the things are described. You can check my demo project, which I think we'll publish after the event. And I hope it was useful. And I'll be happy if you have some questions.
Hello.
Teddy?
It was great, Ivak. Good job. Let's see if anybody has questions. Thank you very much for the presentation.
I can see. Nope. I think I can see the questions.
Are you still there, guys? Did you like the presentation? Okay, let's wait for a while because it takes time.
Yep.
It was interesting for me, like a person who is not developer. So I'm sure everybody enjoyed. Okay. Does anybody has questions?
I'll just stop sharing my screen and I'll try to open a chat. Okay, so if we don't have questions,
we can just say thank you very much, everybody who joined us tonight, and big thanks to Launchy Space because we are here thanks to them here in the Hopping platform. Thank you, Ivo, again for this great presentation. I hope everybody enjoyed. There's one question. You publish the video? Yes, of course. It's gonna be on YouTube in a couple of days, and we are gonna share on the social media. So stay tuned, and you will watch it later. Thank you very much, and see you next time. Bye.
Bye.